Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to use differentials to estimate small changes. And again, the word estimate is very important there. So we're just going to go through an example. Here we have a sphere, and imagine that we have a sphere with a 200-meter radius. And this sphere is going to have a certain volume. What we're going to do here is we're going to estimate the change in volume if the radius changes by 1 meter. Now don't worry about where we would find a perfect sphere with a 200-meter radius. Maybe it's a mini Death Star or something. That's what this actually is in reality not important. So the way you use differentials to estimate changes, you start by writing some sort of formula or equation down relevant to what you're looking for. So here, we're going to be looking for changes in volume. So I'm going to start by writing out the volume of a sphere is 4/3 pi r cubed. And now what I'm going to do is I'm going to differentiate this with respect to r. So the next line is going to read dv dr is equal to 4 pi r squared. That's coming from multiply by 3. That's going to cancel this, right, giving you a 4 pi r. Subtract 1 from the power. There's your squared. Now, this is a first derivative. Remember, first derivatives are separable because they're the ratio of two things, two differentials. This is differential of v over differential of r. So what I can do here is multiply both sides by dr. The new line is going to read dv equals 4 pi r squared times dr. What I'm going to do now is use 1 meter for my change in r, my dr, 200 meters for r, and that's going to give me a dv, differential of v. So I'm going to go ahead and just write that out. 4 pi times 200 meters squared times 1 meter. If you give me a moment here, I'm going to calculate a value. And I get 502,400. 502,400 cubic meters. The idea here is this, that the actual change in volume is going to be approximately equal to dv, as long as our change in r is small. Right? And again, if you're wondering about this, go back and review. I've got a video on differentials that will kind of explain that. So as long as we stay, as long as dr is a small value, in this case 1 compared to 200, it's pretty darn small, then dv and delta e are approximately the same. Now, which means I can say this is approximately our change in volume. Now, sometimes questions like this ask about percent changes in volume. The percent difference we would get by taking our change in volume, dividing by our actual volume, our starting volume, and multiplying it by 100%. So in this example, that's going to be 502,400 cubic meters. There's our change in volume. I'm going to divide that by our original volume. Now, I don't have a number sitting on the page for that, but I can just calculate it. 4/3 pi times 200 meters cubed. What I'm going to do now is just get a decimal out of this. If you give me just a moment. Okay, I get 0.015 out of this. To convert this to a decimal, we're going to take it and multiply it by 100, so that's 1.5%. So basically, if we change our radius by 1 meter, we would expect about a 1.5% change in volume. So hope this video helps demonstrate how to use differentials to estimate changes. And again, small changes, that's very important. Conceptually for why we can use the differentials. Have a great day.